Hey everyone, and welcome back to another episode of Dr. Carl Explains, your YouTube channel where I teach GCSE science for free. Okay, so today we're going to be going through chromatography. Grab a pen, grab some paper, and let's go ahead and dive in. Okay, so some quick key points first of all. Chromatography can be used to separate mixtures and can help identify substances. It involves a stationary phase and a mobile phase, and we'll go into more detail in a second. Separation depends on the distribution between the phases. The RF value stands for retention factor, and I'll talk about how we work that out in a second. And then different compounds have different RF values in different solvents. So remember, a solvent is something that can dissolve a substance. And a compounds may separate into different spots depending on the solvent, but pure substances will only produce one single spot. Okay, so setup and how it works then. So first of all then, what we've got is we've got our chromatography paper here, and all we do is we draw a line at the bottom across of it in there like that in pencil. It's got to be in pencil because pencil is insoluble. Then all you do is you basically put in some samples along here, very small samples, normally of like inks or paints or dyes or stuff like that. And you would say, let's do a red one, a blue one, a green one, a yellow one, for example. And then let's say this one is an unknown just under here. Then what you do is you pop that in a beaker and you have some solvent here. Now you need to make sure the solvent goes under the line. And then what you do is you allow a little bit of time for the solvent to move up through the paper. The solvent moves through the paper, and then all you do is you draw a line at the top where the solvent has got to. Okay. Now this paper here is known as the stationary phase. That's the stationary phase there. And then this whole section here of the solvent moving up through here, that is known as the mobile phase. So that's the solvent. So what will happen is the solvent will move up through the paper, and then what you'll be ended up with is something like this, where you'll have some dots along here, where you might get some different substances in there like so. Now I'm just making these dots up, for example, but let's say red gives a dot like that, blue like that, green like that, and yellow like that. And then in your unknown, if you then had two dots here and a dot here, for example, what this would mean is that your chromatogram, your unknown sample, must contain the green and yellow inks, because those dots correspond with these dots here, and you don't have any dots corresponding with the red and the blue ink. Okay, so how it works then, the solvent moves up through the paper, that'll be one mark, carries substances different distances, and it's according to how soluble the substances are and the attraction to the paper. So the more soluble a substance is, the higher it will move up with the mobile phase and up through the paper. The less soluble it is, the further down it will be, and if it completely stays on the line down there like that, for example, then it would be insoluble in that solvent and wouldn't move at all. Okay, next then, so working out an RF value, so let's take my chromatogram here, and let's say I've got my sample just here. The first measurement you would do is you would measure where the solvent got to and from the pencil line at the top, okay? And that would be the distance of the solvent just here. So let's say, for example, that is 6.2 centimeters. You would then get your ruler and you measure from the center of the spot just in there down to that baseline again just there, and let's say, for example, that comes out at, well, it'll be probably roughly 2.8, something like that. And then all you would do is you would do 2.8 over 6.2, and so on my calculator, 2.8 divided by 6.2, that comes out as 0.45 RF. Now there's no unit for it, we just think of it as RF, it's a retention factor, and basically what that number tells you is how far it's moved up here, and that number should always be the same as long as you are using the same solvent each time. Now what the exam board could ask you to do is they might give you the RF value, and they might give you the distance of the spot, and they would ask you to work out the distance of solvent instead, and therefore you would have to rearrange this equation and then find out the distance of solvent. But all you have to know is these measurements, distance of the solvent, distance of the spot, and you should be able to work all of that out. Okay, so how to set up and run a chromatography experiment. So first of all, you draw a line in pencil at the bottom of the chromatography paper. So you get your paper like so, like this, nice and easy in my crude drawing, and you draw a line at the bottom. Place a small sample of known ink, so that's doing that along there, and each ink on the pencil line, so you'd label them, so that would be like red, blue, green, and then your unknown one. Place a small sample of unknown ink on the pencil line, add the beaker, and then you would add your solvent, making sure the solvent is below that pencil line. Allow the solvent to move up through the paper, and then you draw your line at the top there. Use a ruler, and then you would measure all of these different samples here, like so, from the distance from there to there, and then from here to here again, and you work out the RF values that we just went through. Once we've got the RF values, you can then compare the RF values of your known samples to your unknown sample over in this one over here, and then you can work out what is in your unknown sample. Now, the final bit that they might ask you is some errors. Now, it could be, for example, that they might say that this line, instead of using pencil, it uses ink, and so what would happen is the ink would also rise with the rest of the sample. Or it might be they ask you what's an error here, and this would be that the line is below the solvent line, so all of the ink would then essentially dissolve into the solvent and ruin the chromatography experiment. Okay, thank you very much for listening. If you do need any more help, please do check out my other videos.